That's Ryan, by the way. I'm
Hey,
Sam.
Ryan. Hey, Sam. Good to meet you both.
Yeah, you too. Thanks so much for coming on.
Yeah, no,
Um,
I'm very happy to come in and talk.
yeah, I've heard you talk about Redwood like every week for the last month, I think, because I've been doing my podcast rounds, during quarantine, and I've been getting a lot
Yeah,
of
yeah.
podcast listening in.
That's my goal. Got to hit them all.
Yeah,
Got to collect. It's like Pokemon. It's Pokemon for podcasts. Got to collect them all.
it's good. I think it's good that you're thinking about the marketing angle because that's an important part of open source and successful open source, and making an open source project that actually works and is sustainable. We've been in lots of open source communities, and the best tech isn't always what's most important, kind of on the face of it, right? It's the best tech. Really, lots of factors go into it, and helping people understand what problems your tool solves and getting people excited about it is part of all that.
Yeah, absolutely.
So,
I think marketing is a part of any selling anything to anyone. No one's going to use your thing if they don't know about it, right? So step one, make sure they know about it. Step two, make sure it's awesome, right? I think this is the danger that a lot of people get into with open source is you think that if you make something cool, then everyone's going to come and use it. But right, visibility is everything. And I mean, even as much as I've been talking about Redwood lately, it really only scratches the surface of people that know about it, right? And it's like you might have people that pay attention to tech news and they might see it bounce by once here, once over here, listen to it on a podcast, or maybe saw it on Hacker News or whatever. But that's a small percentage of the total number of people out there who could potentially use Redwood or any project. And it takes a long time. It takes months and months, if not years, for people to see and understand that there's even other options out there.
I feel like especially today, as opposed to like when Rails came out too, because things are more saturated, I guess, in some sense. We don't have like 3 news networks anymore. It's like you can find things on YouTube and Twitter all over the place. And in the same way with tech, if someone has an impactful first demo like DHH did with Rails, it might not reach the same percentage of developers right away,
Yeah, well, and there's just so much more of it now. I think every year we reach these saturation points of how many new things there are. There used to not be that many new things, It used to just be every couple of months you'd see something interesting go by, but now it's like every single day.
Yeah.
There's something new, something awesome. And I mean that's kind of the pickle that we're in as developers, which is we love the newest and best stuff. And if you do like being on the bleeding edge of things, then do you ever even have a chance to become expert at something, or how do you know what to choose, right? How many web frameworks are there now, right? When Rails came out, their frameworks barely even existed. Like, what even was a framework, right? I mean, I think that was what was so powerful about Rails, is that it brought this framework mentality to what we were all just building on our own with PHP or Perl or whatever. We were all just hacking together something that worked for the things that we were building. And then here comes along a framework and is like, oh, don't worry about all that crap anymore. Just build the thing that you care about and leave that to the framework.
Yeah, that really shines in Redwood, because Ryan and I, spent some time earlier going through the tutorial and kind of both coming from Rails backgrounds. Ryan much more than me, but I've written my share of Rails servers. There's just lots of little moments you see. You're like, oh, that feels just like that Rails experience. And yeah, we really liked that. So I could tell it had a big influence on you and the team that designed both Redwood and even the tutorial in terms of what you emphasize and what matters to me, the reader, and what doesn't matter,
Yeah, absolutely. I mean, I grew up on Rails. Rails turned me into what I am. GitHub was built with Rails. I mean, Rails is what has gotten me to where I am and allowed me to build amazing products. But I don't want to write Rails anymore. I want to do things in a different way. And so when we talk about Redwood, right, we're not trying to say that Redwood is the Rails of JavaScript or the Rails of Node or whatever, because it's really not, right? Redwood is its own thing with its own philosophy that maybe takes hints here and there from Rails, or when we come up to an arbitrary decision about how we might want to do a specific thing, then we might say, oh, well, in Rails, we did it this way, and that felt really nice. So if the choice is arbitrary, then we may fall back to some of these things that Rails made familiar to people. And that's nice. But architecturally, Redwood is very different. I think in the way that it thinks about JavaScript, it's very different. And none of this is to denigrate Rails or try to say that Rails isn't an amazing achievement, because it is. Rails changed everything. It changed the entire landscape of what we can do as developers. But there's different things that people want to do today, and Rails is going one way. I think Redwood is trying to go kind of a different way, right? Where Rails is sort of like, what's the minimum possible amount of JavaScript that you could make a person write? Because it's built on the philosophy that Ruby is the greatest and best thing in the universe, full stop. And Ruby's great, but I got, every language has its problems. Ruby has plenty of problems. The metaprogramming in Ruby is, I don't love. Like it's where you get lost, and it's where you suffer from a maintenance perspective. Like even just trying to track down where a function is defined. It's like, how do you search your code base for this specific function that was metaprogrammed into existence? Basically impossible. And it makes it really hard for the tooling as well to track it down, because it's like, I don't know, like this thing could have, you could change this class from anywhere. Like how do you do that? And I think that tooling will become more sophisticated over time, but I don't know, like going through and working in a Rails code base that has been around for a long time, I just don't enjoy it. It's too easy to get too complicated. And it's possible that at Basecamp that their applications are amazing and perfect, and like and I would expect them to really be the best instances of those. But I think as a person who's not building the framework, you take shortcuts, right? And you don't necessarily know what the best practices are to achieve the best kind of long-term maintainability. And you're just trying to build your startup or your application or on the weekend or at night, and you don't have time to become a PhD in Rails best practices. And I don't find Rails guiding me a lot, or anyone, on some of these things. And so you end up with a lot of tightly connected code. And again, right, like if you do Rails the right way, it can probably be amazing. But it's not guiding me as much as I think a framework can guide you. And so with Redwood, we're trying to do a little more guiding architecturally. And so if you noticed on the API side of things, we have a web side and you have an API side. The API side is a GraphQL API with Apollo. But the way that you write your business logic is by thinking about it in terms of services. And I need to do a lot more writing about the philosophy of the backend and the philosophy of code organization and maintainability, which I haven't done yet. But by thinking about your backend in terms of services as a high-level concept, services end up being an internal API that you have even within your code-based backend, so that one chunk of your website business logic can call into another chunk of your website business logic as if it were an API. So it's encapsulated, but at a level much higher than models, for instance, or controllers.
Yep. Maybe before we get too into it, just to give listeners a little bit of an overview, we can talk just a little bit about the high-level architecture. But you've already done that on other podcasts, so I didn't want to spend too much time kind of rehashing what you've already done. We'll make sure to link to all those other ones in the show. But just to reflect really quickly on what you said, I related to so much of it. Going back to an older Rails app, or even nowadays when we're writing heavier JavaScript apps with Rails backends, and if you open that Rails app after 6 months or a year, it does feel a lot more foreign. Both because I'm not working in it, but also because Rails and Ruby isn't, advancing the same way JavaScript is. And a lot of us do want to work in JavaScript because it's run in the browser and it gives you all these capabilities. So for all those reasons, I just relate a lot to what you said, And So talking about Redwood, again, just kind of a 30,000 foot view here, it's really what a lot of us in front-end JavaScript have been doing for a while, where you have kind of a client a fat client or a JavaScript application running on the client, which needs to talk to an API. But the kind of unique thing with Redwood is that it's giving you both. And from the perspective of the developer, there's one coherent developer story, one developer experience. You're running commands to generate API endpoints or front-end pages from the same spot in your terminal, and it's putting all the files in the right places. So if you're like a React developer or Ember developer listening to this, this is basically that plus the backend API that you either already have or are working on separately. It's kind of both of those going together, right?
Yep.
And so, yeah, the point you were just making is really interesting, because actually one of the notes we have here as we went through the tutorial was the last time we built a larger API that was in service of a front end, maybe what you've heard call a backend for a front end before, which is like just an API just for consumption's sake. Right. One of the blocks that we ran into is when you need some sort of escape hatch when your resourceful routes on the resources you're exposing don't completely neatly line up with what you need to do. So you need to do CRUD operations on a user, you need to do CRUD operations on a subscription, and all your tools are going to handle that just fine. But as soon as you need to create like a sign up, and like from the perspective of the front end, I need to sign up a user, which involves, creating a user, creating a team, joining them together, and then creating a subscription kind of all in one. You are left with this choice, which is add all that logic to the front end and do it kind of in a waterfall, which adds a lot of failure states to the front end, adds a lot of complexity. You lose out on a lot of the validation that you can do from the back end, or you go outside the lines of these API frameworks and do your own custom code that kind of cobbles these together. And one of the things we noticed, which you just pointed out, which is that the services in Redwood basically are exactly abstracted. They give you this abstraction for solving this problem.
Right. Yeah, exactly. And it really, a lot of this comes from the desire to write React on the front end. You can look at that and then trace why the rest of the framework looks a lot of the way it does.
That's like really React, interesting.
Yeah. Well, and so this is why it differs so much from Rails, right? Rails wants the minimum amount of JavaScript, and Redwood kind of wants the maximum amount of JavaScript and to be able to write React. But it starts with React, right? And it's to say, well, React is great. It gives us things that we've never had before in front-end web development, things that are super nice, composability. It's all compartmentalized. We have these components now that we can reason about. We have one-way data flow. We have reasonable ways to think about state. The context stuff makes a lot of the operations that you want to do easy. And one of the most powerful things to me that I don't think has been fully explored as much in a framework context as it could be is to use something like Storybook to do your initial component development outside the context of your application is such a monumentally powerful idea that I want, remember the last time that you were working on a Rails app or something, right? And you're like, okay, I need to design this page, and it's deep in some part of the website. And like, in order to get it into the state that you want it to be in order to design it and code it up is like, jumping through those hoops is the worst, right? You're like, okay, I got to create this user and get them into this state, and they have these permissions and also these things, like they've done these operations on the website, and so you're
especially when we pair with people, other clients, people working on existing applications, that kind of thing is a crazy pain point. Honestly, it really is.
Right. It's horrible, and it's a huge waste of time. And you end up hard coding stuff, and then you have to change it in the code, like to get it back to a normal state, and then you forget like which things you hard coded and which things you set up the database to do. But in a Storybook world, that sounds so nice, doesn't it? In a Storybook world, you can do all of that with your React components, and you have all of the state available to you via props or some external context. And as long as you can pass those things into that component, you can get it in whatever state you want. And you can even have toggles and text boxes that you can enter the data as you see fit and get it into any state that you want with no pain at all. Right. And then be able to share that with all your designers so that your designers can all go in there and see all of the components that you have available and all of the options that they have. So it becomes a catalog of your entire design system in a natural way without wasting any cycles.
I think it's really interesting to think about what you said, which is like you're coming at this from like a React first mentality, because the idea of starting with the front end is really meeting a lot of teams where they're at today in terms of the separation that we see in teams. It's not like a Basecamp startup with two people who are full stack programmers and who want to do everything together, all on the front end, all on the back end, as simple as possible, and come up with like the minimum experience they need. It's like, it's people who want to use something like React, again, for all of its capabilities to make really rich user experiences on the web, things like Notion. And people are going to want a lot more control over their UI. And so, yeah, a framework that embraces that, I think, is really powerful. And you see a lot of these kinds of things fall out from that, you know?
Yeah, but the problem right now is that getting these things integrated takes large amounts of time, as can be evidenced just from our work on Redwood itself. Like to get Jest integrated with, and Storybook and the front end talking to the back end via Apollo and making that a nice experience, and some of the nice things that we add with cells or auto importing pages in the routes file. When you do nice things in your framework, it makes the integration task much more difficult, because now Jest has to know about all of that magic. And if you put that magic in Webpack, Jest doesn't know anything about Webpack, and Webpack's not running at test running time. So we've gone through a long path of dealing with these things, and we're still working on tests. We've now just got tests kind of in a minimally functional form. And Storybook, we have attempted to integrate Storybook once and failed. And so we will attempt again and make it work. But if you want a nicely integrated framework-like experience today in the React world, it is a huge investment. Huge, right? And that's why people aren't really doing it, because they're trying to build their startups. I have the luxury of being able to spend some time doing this and putting a team together to be able to work on this, because I want it to exist for myself. It comes from a lot of ideas at my current startup, Chatterbug, that we're using. We're not using Redwood currently. It's still a little too young, and it's built. We started working on it years ago, and it's built with Rails on the back end, but Rails is quickly becoming just a GraphQL API, and all the front end work is done in React. So our design methodology is matching pretty closely what building a Redwood app would be. It's just still Ruby on the back end, but I wish it was in Redwood, because from these guiding architectural principles, it would be super helpful, because our backend code is not super awesome, because it started out as hacking things together to get them work, which is how every startup starts. And then it just ends up kind of spaghetti over time, even though we spend a lot of time trying to tackle technical debt. Like it's just, if the framework doesn't help you and point you in the right path, then you'll always be fighting it. Yeah. But I wanted to continue a little bit of just describing why it's why it derives from React, just to go through the stack for anyone who's not familiar with Redwood. So a Redwood application is React on the front end, and you then talk to your backend, which is a GraphQL API. And the way that you talk to it is through what we call cells. And cells are a declarative way to do data fetching. So you just export certain named functions from your cell, and your cell then masquerades as a React component. So you mount it just the way that you would a normal React component, but it then is in charge of the data fetching. And you just export different states. So you'll export the success state, or a failure state, a loading state, and then you'll export your query, and that'll be your GraphQL query. And the framework then orchestrates running that query and then passing the result to any of those components that are defined as the exported success, failure, loading, or there's even an empty state that you can define. So you're not dealing with a lot of the imperative code to check whether it's a failure, and it's just a bunch of boilerplate code that makes things messy, and you end up with either a bunch of external components that you're cobbling together, or you have what is essentially a bunch of components all in the same file as a bunch of things that then you just have to imperatively kind of pull in. And it's just more messy than it needs to be. And it's fairly lightweight in what it does. It's just a simple higher order component. But in being thoughtful about these developer experience matters, this is the overall intention, right? But when you use React, you kind of want to use GraphQL because GraphQL matches the way that React thinks about the world. And if you can make a component responsible for fetching its own data, then you have true compartmentalization. But then you want to test it. And now you run up against like, okay, well, what do I have to, am I mocking my data? Am I like, what am I doing with jest? Any magic now? Like, how do I test a concept like cells? Or if you're writing high order components that are doing fancy things, like how do you test those, right? So you want to do those things, but they're hard because integration is hard. So we'll handle those things for you and just make it really easy to mock out your backend. And we're at the very beginning of that journey. But then on the back end, you have a GraphQL API. And that's really it. Like you can create other functions. And our deploy target right now is we're sort of optimizing for deploying to AWS Lambda at the moment through Netlify. It's sort of where we started. And there's nothing about Redwood that would prevent you from being able to deploy in any kind of traditional pattern onto containers or EC2 instances or whatever you wanted. But to me, the idea of a JAMStack style development methodology and deployment philosophy could be so powerful because it's just write your code and then push to GitHub and then it is deployed.
Yeah.
With the caveat that the database is not quite there yet. And we can talk a little bit more about that.
That was one question we had. Why don't you finish and there's a couple of things we can come back to.
Yeah. So then we use Prisma for you to talk in your business logic. So you create these services and the services then are mapped automatically for you to your GraphQL as resolvers. So you're not writing resolvers in the normal way you would with Apollo. You just write what look like normal JavaScript functions and export them from your services. And now you have these services that the GraphQL API knows how to use to complete your GraphQL API, but you can also call these functions from your other services. And that's what I mean when I talk about it being an internal API. It ends up being an internal and an external API. Because you can call them just like normal functions.
Yeah, the service functions, it basically felt like what Redwood was doing, wiring all these pieces together, is that it was giving you the data from the request and letting you, interact with your database via Prisma. But as far as like translating the actual GraphQL request and deserializing it and validating it, that's all offloaded to Apollo. But I didn't even know I was using Apollo as I went through the tutorial. Yeah. Now, I did know I was using Prisma because that's part of the developer's interface. And if I want to do something with my database, that's how I would do it. But it feels like you were able to basically make the Apollo GraphQL translation layer basically transparent, which was really cool.
Yeah. Yeah, it is. And so you're not doing anything Apollo specific as a user. If you go look at the code, you'll see that it's orchestrating that for you, but kind of pulling your various services files together to create your resolver map and looking at your SDL, your GraphQL SDL, right? Your schema definition language for GraphQL, and separating it into multiple files. Like all of that's done for you. And so you just write SDL in separate files that would represent your services, right? So let's say you have like a billing service, for instance, like that might cover multiple databases. It might cover like a transactions database and
users,
and a couple other
subscriptions,
tables, right?
Tables, right?
Probably not users, right? You'd probably have some kind of a user service of some sort that you'd split off, but you're going to have 3 or 4 tables at least to cover your sort of billing service locally. And then, maybe using Stripe externally, but you want to keep track of things locally as well. So you'd have a billing service, and that's an abstraction above tables. So then you would, in your service file, now you're implementing the business logic to orchestrate what happens amongst those tables. So that's kind of the concept there.
So there's a similar concept to the controller method in Rails, except again, there's an abstraction layer between it, not just being tied directly to like a database table.
Yeah, kind of like controllers, but it's really it doesn't feel. I mean, I guess you could think of it that way, kind of. But it's really about controllers aren't about like they're not conceptualized as services. Right. And they're not intended as an API. It's the thing that you make a request and it goes to a controller that handles that request. And then, you spit out a view. Like it's very connected to the request response cycle, whereas services are really not. Like it's part of an API. I suppose you could draw some parallels there, in a sense.
Well, also, go ahead, Ryan. I think you were.
Yeah, I was going to say, I think when we were going through the tutorial, that was sort of our mental model because we were working in like the context of a post with a post service. But as you're talking about billing, I can totally see like, oh, there's one service and there's, multiple tables underneath, and we don't have to. The service handles all that for us. We don't have to think about that if we're calling that service from another service in the app.
Right. It's the reason that they're kind of dissimilar is that you wouldn't call a controller from another controller.
Mm-hmm.
Yep.
Whereas in services, you would call a service from another service, right? Like, so
that makes sense. And the whole thing about skinny controllers, and this is part of the refactoring pain that you hit as your Rails app grows in complexity, is like keeping your controllers small, and those controller methods end up delegating to a quote service layer. But Rails doesn't really have a first class notion of services. People make up this for themselves. Yeah. And so I guess that's kind of what this fits into.
Yeah. You can add a services layer to Rails, but it's not something that they talk about. It's not really a first class thing. And of course you can, it's code. You can organize it and do any of these things you want. You could do something very similar in Rails if you wanted to, but they're not evangelizing that. That's not really part of the philosophy of the framework. And so it's really, services are kind of a combination of what a controller and a model would do, but also it's trying to avoid also being fat model, because the problem is that when your controllers are small, then your models get big. And now you've got your models calling into other models, and now you've got really tightly connected models. And if that's your layer of abstraction, then you end up with too tightly connected models. And now you forget where your service boundaries are, really.
Right.
Like everything is everything. So for us, it's like, think from the very beginning architecturally about your application as a collection of services. If you start there, then as your app gets more complex, then you can eventually tease those services apart if they get too big. You could make one service, you could turn it into 3 services where you separate out the SDL for the GraphQL into a couple of different things, and then your services file splits into 2 or 3 or whatever it needs to. And it allows you to then isolate those things. And when a person is working on the billing service, they know what their area of responsibility is. They know how to interact with other things outside of it through other services. So if you need to update a user from your billing service, then you know how to do it. And you know that you're not going to go straight to the table. You're going to go through another service. And that service is going to tell you like, hey, user service, update, this thing about the user as a concept, not the user as a table and not the data, but like update this conceptual thing about a user. And then the user service can say, okay, I know how to do that. And you don't ever have to know in the billing service how a user is implemented or what tables it's stored in. And so it means going kind of up the stack of your business logic and then letting the other service go back down.
I see. So basically the services layer is like, that's my business logic. It's like a set of functions that implements my business logic. And the fact that like Prisma is talking to a database that wraps like the schema, or the fact that Apollo is like deserializing data from GraphQL. Both of those things are basically like implementation details. And when it comes to me building out my backend functionality, I'm just thinking about my services. Some of those services might happen to basically delegate GraphQL requests to database updates, but that's besides the point. The real point is like each service is just implementing my business functionality, and that's what they're there for. And since they can call each other, there's no limit to how they can grow. Like they can accommodate things that interact with multiple tables or multiple services or whatever.
Yes. Yeah.
Interesting.
That's exactly.
I didn't really understand that coming away. I mean, because well, it's cool, right? The scaffolding, like one of the things I have here, our kind of first real like wow moment going through the tutorial was the auto-generated migration. So you kind of start.
Prisma offers that. We can't take too much credit for that one, but it is one of the reasons why we selected Prisma.
I mean, it's amazing, and honestly, it's something to be said to not really having ever used Prisma, but having basically been successful with it. I mean, I think that's like the best thing you can ask for in a situation like this, where Redwood is doing a lot of this, like you said, this complex integration work. but I can just follow a couple commands and I have all that stuff working. And I've written Rails migrations before, and this felt nothing like that. We just changed the schema, ran a command, and I mean that was really really amazing. So going through that, you get the command, you migrate up. Now you have your SQL file generated for you, or maybe you get that once you scaffold it. But basically, I was kind of thinking in terms of the database and then like, how do I update the database? But really I should have been thinking, okay, once we get the services here, this is really my business's API. Like you could almost put it in a separate folder from the rest of the things. And this is really what I want to focus on. So if I'm going to be making a page for signing up, I'm going to have a sign up function in my service layer, basically.
Yeah. And it would be like, really the way that I would do it and think about it is, I have a client. I have a front end client. It's a web browser. Let's say in the current instance of Redwood, we will eventually support other sides. So we call them sides, right? You have the web side, which would be the front end, and the API side, which is the back end. But we can in the future have other front end sides, like a mobile side that uses React Native, or we could have a command line side, which uses something and makes it really easy for you to use these same patterns on the front end. And they all then just talk to the same GraphQL backend. And so that's another architectural reason why we use GraphQL as the protocol for the front end to talk to the back end, because it means that now you can create any kind of client you want and it just talks to the GraphQL API, right? So the way that you would think about designing what your GraphQL API wants to do starts with your needs on the front end. And if your need on the front end is, I need to sign up a user, or I need to make charge a user for billing, or I need to, make a comment, or I need to, whatever it is, then you say, okay, here's what my user interface looks like, right? I like to start with design. I always do design first as much as possible, so that you can think
you're on
without
you're
thinking
on a podcast
about,
called Front End First, so you're preaching to the choir right now.
See? Yeah, but that's, right? Because then you're unfettered from the limitations of the thinking once you start writing code, right? You need to think about information architecture and user experience before you start thinking about how to implement that, right? In an ideal setup. So you have your front end and it wants to do a certain thing. It wants to do a certain operation to manipulate data or fetch data and show it, right? And that's like every web app is really just those two things. It's like, get me something from a data source and mutate it, change it a little bit, and then put it on the front end with, some nice things around it.
Yeah.
Or it's user wants to do something and presses a button or whatever, or some external thing, some external event causes it. But then here's data that exists right now, either change or add that data. Like that's every web application in existence. That's all it does, right? Essentially. So then you start thinking about, okay, I want to do a certain operation. My front end looks like this, and I need to make this change on my back end. And so what is the GraphQL API that I need in order to accomplish that? And then you start designing up your back end, and over time you can start to see it evolve, and you might tweak a few things here and there, or, as you're building out your queries, they might look like different things. You can enter them at the root. You have these different root level queries that solve different problems for you, but it's all just data fetching. And that's really like in GraphQL, GraphQL is almost two completely different things. It is this query language that allows you to get hierarchical data back really nicely that can match exactly what your user interface wants, right? You say, here's the data that I want, and here's how I want it formatted to make it as easy as possible for you to then consume with your React components. Mm-hmm. And then that's one thing it does. And then a completely different thing that it does is the mutations. And the mutations are essentially just remote procedure call, right? Mm-hmm. So it's like a query language plus RPC. It does both. And it does both really, really well. And it's type safe. And you just can get really nice things. You can document it. And again, once you get into larger projects, you start to really want this level of separation between parts of your application. And so GraphQL acts as that knowable, documentable separation between front end and back end where you could, and then it becomes very easy to have different teams that work on those two things, right? You can have a front end team that knows how to design and put UI together.
Yeah.
And then says to back end team, hey, I need to do these things. And they'll say, okay, we will provide you the GraphQL queries and mutations in order to do exactly those things.
Yeah. Having not worked on a large GraphQL app like at a job, one thing I hear folks who have say is how important the typing is. And I wonder, question for you, like having now worked with GraphQL on your new startup compared to, let's say, Active Record from Rails, where Active Record is giving you a single interface to a model and letting you read and update that model. And it has this notion of, it's really built around a notion of an identity map where you say user.find1. Now that's going to be in Rails's cache in Ruby memory that you're going to be able to like set first name to and call .save or .rollback. You're interfacing with this singular identity of a model. And that's how you're doing both your reads and your writes. And Rails has your back a lot of times here because if you try to refetch something that is already fetched, it can help you. All of those kinds of active record methods are resolved through this single layer of a cache, basically. Whereas with GraphQL, at least my impression and from my experience that I've used it, limited experience, it's much more like you're saying it's separate. Different teams can be doing different things without having to think about each other. And maybe that ends up being better by the way that we're building these sites, which are, you want a team to be able to go and build this part of the page and not have to worry about any other part. And because we're kind of working in a distributed system, it's actually better that our tools do that. So have you ever missed that like identity map notion from Rails where if you have a record, like a model of ID1 and you just want to update it and save it and I already have it, I can just do that easily?
No. And the reason is because of what happens with your models, right? Like it's cool that you can do that, but now your model becomes responsible for basically everything.
Yeah. And
it's just a bag of functions that you're attaching to your model that is responsible for every data mutation. And to me, it's the wrong, I think there's a better way. And that way is to think more functionally, where your data is not like the table that you're storing your data in isn't necessarily how you want to think about the world. You want to think about how what operations you're doing, right? It's the operations that are the most important things because that's what maps to what you're trying to do. Like, again, what I said, you are either fetching data, in which case we're not that worried about, that's not this conversation. This one is you're trying to change data.
Right.
And if you're changing data, it's the changing that is the most important thing, right? And it's conceptually like, what are you trying to accomplish? What is the action? What is the verb? Right? The verb to me is the more interesting bit. And then the data, you can then that becomes implementation details, right? And so Prisma is not an ORM. It's not producing objects as such. I mean, it's producing Ruby objects, but they're just data. There is no functionality associated with them. And so in a Redwood app, you're writing functions that will manipulate that data. And those functions become the first class elements. And those might need to read from several tables to do what they need to do, and then change data and save it out. But it becomes about the verb and then fetching whatever data you need to do your work and then writing your data back to permanent storage. And so it's inverting kind of the noun and the verb.
Definitely inverting it. I mean, one of the big lessons from Rails was like try to constrain your application actions into the standard nouns and verbs and not create your own. So if you need to subscribe someone, you would never want to write a method def subscribe on your controller. Instead, you want to create a subscriptions noun so that you can just create it or delete it or update it so that all of your verbs are the standard resourceful ways we do things over REST. Whereas here you're saying the inversion is like, no, subscribe is how you talk about your domain. Why don't you just go to your service layer, write a subscribe action, which your front end can call, and there you can perform all the logic. Is that kind of what you're saying?
Yeah. And the server, depending on how you cut it, your services might end up being certain types of nouns, but they're like these higher order nouns. The problem is, I think in the Rails world, in the Rails imagination of this, your nouns are tables. And that's the problem, is that your nouns often aren't tables, right? Your subscription might actually require 3 tables, or, a billing, like to bill a customer. Like that's really, like, you don't care. As someone who's in a different part of your website where you're like, I need to kick off a bill for a user, right? Like in your mind, you're like, here's what I want. Here's what I'd like to do. I'd like to be able to call one function with the login name or whatever, the ID of the user and what they're being billed for. And that's it. I don't want to have to worry about anything else, right? And so that's what your service level thing is going to do. Mm-hmm. And then beneath that, you can say, okay, well, the way that this thing is implemented is that like this goes in this table, and this goes in the transactions table, and this goes in the whatever, table, some audit log, right? But if you're like, okay, a subscription is a model, and then what happens when you realize that you need to also update the audit log with your subscription? Now you're like, okay, well, yeah, my subscription is a thing, but now it needs to also, the subscription model is going to update the audit log table. And now that, like, right, you can see how this starts to expand from just one table into multiple tables. And now every table, every model, which is really masquerading as a table, or many of them are, but they're really not. And then they're just sort of make-believe, like what are they? Now they're masquerading as services, but they're not. You're not imagining them as services. And now everything's connected to everything.
Yeah. Where do you fire off the email? Do you do it on the model after it's created? Do you do it in the controller? Ryan, what were you going to say?
I was going to say, and once you start pushing more business logic to the front end, now you have the front end dealing with all these models and creating them and then having to communicate it back to the back end. So there's something really nice about it. Ties back nicely to that front end, starting with the UI, starting with the front end, and that you don't have to think about the back end until you've already sent that GraphQL request and you're already in the service. And then you can think, okay, how am I going to store this data? Something really nice about that.
It's just a beautiful point of separation, I think. And in that it's a real separation, you have to think about it that way. You have to think about like, oh, I want 1 or 2 mutations maybe that I need to run that are going to comprehensively do what I want them to do. And that's going to make it really easy for other people that are doing front end things to also do that same thing. Right. And then this becomes especially true when people outside your company want to start building their own clients or integrating with your service in some way. Where if you're writing Rails the normal way, you might end up with a REST API. I hesitate to even say that because, like, when was the last time that anyone ever took their internal REST Rails API and published it?
Yeah.
That's not really what you would do. And so then people today are like, okay, well, I'm going to build my Rails app, and if I want to do it in the Railsy way, then I'm going to build that out. And now I have my web app, and that's great. And that, it integrates really well. If you're using views in the normal way and you're using minimal JavaScript and you got turbo links going, like, it can be super performant and functional and pretty great. But then you're like, okay, this is working out. My startup's going great, and we need a mobile client. Well, guess what you're doing now, right? You're like, well, we're going to use React Native, or, we really want to use GraphQL because, like, it fits the model of a client server super well. And we're either going to use REST or we're going to use GraphQL. And, like, we don't really have a REST API anyway. And, like, GraphQL fits the needs better, and we can reduce the number of, back and forth transports that we need. So now we're going to build a GraphQL API. So guess what? You're building a GraphQL API anyway.
Yeah.
You're just half-assing it because you've already written the business logic once.
Up front,
and now you're like, oh, now I've got to write my business logic again.
Yeah. Yep.
Right. And now you're cutting things in a totally different way than you probably did when you were pretending to be RESTful.
Yeah. We even ran into that, companies we've worked at before going to a mobile client, when you just want to add more rich JavaScript driven functionality on the front end. Let's say you are in a Rails app and you are just writing controller code in Ruby, but now you want to Ajax in the latest videos on the homepage. And so now you start writing these one-off API endpoints. And that's really what drove us towards a lot of this architecture, wanting to just see that this is inevitably where we kept ending up, and wanting to just do it head on from the beginning so that we don't get into that spot again,
Right.
Going back to the mutation thing really quick. So if you are in this world where basically you're leveraging GraphQL to query just what you need for the page. And so that is your interface. And then the mutations are basically another layer. And I do like this idea. I want to think about it a lot more because I've been in this identity map camp for so long. It's kind of really ingrained in how I think. But let's say that these actions instead are like, you're coming from the place of what's the simplest way I could subscribe a team. And it would just be to send a team ID. And then everything about creating a subscription, sending a webhook to Stripe, updating the teams thing and creating a team user or a new subscription and making sure there's a plan that's active in the plans table and it's live and all that stuff. Those are all implementation details. Basically, the front end doesn't have to know any of that. What has been your experience in your app, in your startup, with the fact that, well, mutations and queries are connected in the sense that once you mutate something, it has a chance to invalidate queries that are currently in your app. And so in a traditional server-side environment, sure, you just redirect and repaint the page. But in a client app where you already have queries out, maybe they need to be updated. So how do you usually handle that?
Yeah, well, so right now, the way that you would probably do that is using Apollo's cache. I mean, you can do it that's one way you could do it. I mean, you can use any kind of state management you want. Like if you want to use Redux or MobX or MobX.
Have you all run into this? What do you guys do?
We tend to be pretty simple and just use built-in state. Like we're not generally dealing with so much complex state that it becomes a problem. Like there may be something on the page that you want to update, but you can usually, you get it back and we use just normal state. You'll have some function that a parent is passing down that allows you to update its state, and you hoist state up a component or two. And like that generally solves the need for us. Yeah. And I think that's usually how people should probably start. Like you shouldn't add more complexity than you really need. Yeah. Right. Like, do you need a global cache? Like it adds certain overhead and complexities. And if you're using Redux, like now you've got this whole other system that you're trying to deal with. And those might be appropriate for what you're doing. And if you have a very large app with really complex state transitions and they need to propagate to various places in your interface, then I think that's reasonable. Like Redwood isn't opinionated about that right now. Mm-hmm. It's possible that sometime down the road we would say, we've chosen a state management tool and we've integrated it really well and we think that you should use it. But at the same time, it's all like the front end is still just a normal React thing. Like there's a little bit of magic, but not so much that you wouldn't be able to use all the tools that you're used to using, right? So it's like use whatever CSS and JS thing you want, or just use CSS in the normal way. Doesn't matter. Or BEM or what, like you can use Sass, you can use anything, right? We're not opinionated about CSS. We're not opinionated about state management. The example to-do app, which you can look at on the Redwood JS organization on GitHub, uses Apollo cache to do optimistic updates of like checking off a to-do item. So you can see it there. It's not beautiful. Like the Apollo caching stuff is not doing like optimistic updates and stuff is not super intuitive. So I think that we can probably do better than that. Mm-hmm. And I would it's not impossible that someday Redwood would write its own Apollo replacement. Honestly, I mean, it's not something that I want to do right now, but in the future, it could make sense. Like Apollo is a huge library. I hope that they're addressing that in some of the future releases, but it's giant. Like it's a huge chunk of JavaScript. And if there's one criticism of Redwood or any SPA that is the most legitimate, it is that it sucks to have to ship this much JavaScript to your client, right? Like that's the biggest thing, right? You have to be very cognizant of performance. Like you're not just going to get better performance because you're an SPA. Like you will have the illusion of it once you get things loaded, but your initial page load times are extremely important. Yeah. And we're still trying to figure out the best way to deal with that. Redwood does right now, it does automatic code splitting for you based on routes. Yeah. So it's going to solve some of those problems.
In the tutorial. That's great. That was great to have that out of the box for sure.
Yeah, but like there's more to do there. We're working on pre-rendering right now so that you'll be able to say to a route, hey, I want you to pre-render to HTML at build time and just become available on the CDN. And so you could, even for dynamic routes, these are things that Next.js just came out with now, like in the last month or so. So we're working on, we've had that plan since the beginning, because it's just like, and the way that would work is you're basically just write a GraphQL endpoint that can provide to you the route parameters that you need to render a page. And because you're building the way Redwood wants you to build a page, you're either calling your own GraphQL thing, or you're integrating some third-party API for like Contentful or Sanity or whatever to get content. And either way, you can do that at build time, and then you just bake it in, as long as you know what the route parameters are. Yeah. So you write a simple GraphQL resolver in a certain place, and that corresponds to the name of the route that you want to do it for, and you just tell it in the routes file that you want to pre-render a specific route. It knows to go run that GraphQL. The GraphQL just spits back the route parameters that you need to pre-render. Yeah. And then we can generate all those based on what it would do if you were rendering it in the browser. We just do it server side build time on a computer somewhere, or some build computer. So those are other optimizations around performance, which is I took your question and I raised it up a level to talk about performance in general.
No, that's I think it's interesting that you mentioned that. Of course, Next and Gatsby are doing lots in this area, and it's a big talking point that I see. I think something that's interesting, kind of my biased perspective, and folks that Ryan and I work with. In my opinion, the performance issue in terms of like the JavaScript KB loading, that's basically never been the bottleneck for me in my development. I've done a lot of back office apps for companies. The bottleneck has always been the complexity. So the most appealing thing to me about Redwood is the integration story that it has, the solving of wiring these pieces together. Like you said, having all these different libraries and putting them together is itself a full-time job. So to me, it's way more, like I've seen way more cost in terms of development time than I have in terms of losing out on audience because of slow website performance. So that's basically never been an issue for me. The caching thing was more about the complexity side. So, if you had a notion of a global cache that somehow in Redwood's case, if it knew the data from this cell was tied to the data in this mutation, you could imagine a world where triggering the mutation to update the blog post automatically updated the cell and re-rendered the component without you having to do any state management at all. And there's some interesting libraries out there that have this kind of thing built into it. And especially because GraphQL is typed, they can use like the type names and the attributes to know, hey, this query over here that's being rendered once you redirect back to the homepage, or that's shown on the header, the notifications count, needs to be invalidated and refetched. So that's more of where I'm interested in reducing complexity, because state management on the client can just get bananas,
Yeah, no, I'm with you on that for sure, and I think you're right. Like when you're building stuff, it's generally how long does it take me to get to a final application that users can use, and not like, oh, our JavaScript payload needs to be.
That is not what kills most startups.
500K or whatever, right? Like, So I'm totally with you on that one. And so I, so that's an even better argument for like this architecture can be so powerful. But to speak to to the caching side, so this is another, and you hit on it. So I think you understand this. The cells are an intermediary where we can do more work for you. Yes. Right. And so we can take charge more of the GraphQL and how it's being executed, because it's like you're not telling Apollo what to do. We're telling Apollo what to do. Yes. And so we can run it for you. And when data comes back, like if we tell you as a framework how you need to write your application in order to take advantage of, for instance, optimistic updates or some kind of state management, refreshing certain pieces of data that come back from your query. Like if you were to tell us like the thing that comes back is gonna like maps to this thing, this
almost
data
like the
on
cell
page.
Gives you a function you can use to update the data locally, hits commit, and then boom, once it's successful, the cell updates, something like that,
Yep. Right. But the beauty is that we're in that flow already. Totally. And so future versions of Redwood, maybe you just upgrade and you have better performance. Or there's like the waterfall problem, which right now a current Redwood application would suffer from. The waterfall problem being, if you have a component that's responsible for its own data fetching, and it has subcomponents that also do their own data fetching, then you're going to wait for that first outer data fetch to happen and complete and start rendering before your subcomponents start rendering and then kick off their own data fetching. And so you have to wait like one at a time, right, in this waterfall fashion. Yep. But you don't need to do that if the only thing that you're relying on is data that could be known from the beginning. So let's say it's like a user ID, and you could kick off, like think of an Amazon homepage or something, right? It's like you've got your whole page, and then it's got some like user information, and then you've got this chunk of the website that's going to tell you one thing, and this chunk that's going to tell you another. But if you've got some outer component that's wrapping it that only needs your ID, it needs to finish before any of its children can start, but all it ever needed was the ID in the first place. So like, why is it
not
waiting?
Parallel? Yeah. Mm-hmm.
Right. And so Facebook's Relay does some really fancy stuff to accommodate this. And Relay is cool, but Relay is like way too complicated for what I want to sort of give to the world as far as usability goes. Yeah. And so we will at some point, I think, start tackling some of these problems.
Hoisting the data loading to the root, basically.
Yeah.
I have a question about cells. I was kind of expecting that they would be almost like a hook in React, and I was wondering kind of how they evolved and if they started out basically closer to like the use query hook from Apollo. I found it surprising that you have the query, but then you also have the rendering, and so it almost felt like those were two separate parts. And just kind of curious about how the cells evolved, the design there.
Yeah, we went through kind of a lot of different paths to get to where we are, and also a lot of names. It was really hard to pick a name. We're like, what is this concept? You know, like, what do we call it? And we came upon cell, and it was just like, I don't know, what does cell mean? It doesn't really mean anything. So therefore, but we started with used query because it's really elegant. You know, with Apollo, the used query stuff makes it really nice. You know, when we started working on it, hooks weren't even a thing. Like, we started working on Redwood a year and a half, almost 2 years ago now. And there was only render props. It was like, okay, these are cool. And it allows me to do certain things. And that was kind of nice. And then the hooks came out and we're like, well, we have to use hooks because hooks are amazing and way simpler. But then that made things less nice, actually, because it became more imperative. It's like the render props were declarative in how you wrote your page. It just went down the chain of like your componentry. But once you started using hooks, now you got to declare the hook up here. Now you get data out of it. And now you got to test the crap. So it ended up being more imperative, which we didn't like, even though it was simpler in some ways. And render props have never been beautiful,
right?
Honestly, right? And so then we started thinking like, okay, you know, what I really want to do is like, I have my success state and I have my loading state. And we've been thinking a lot about like how you design your loading states because they become so important when you do an SPA and you have data fetching, component-based data fetching. Like, everything wants its own loading state, which can be amazing. Like, it gives you this really great user experience. Right. So it's like, okay, I'm always going to have my loading state that I'm really going to care about. I'm going to have my success state. I probably have some failure state that I want to deal with that I'm probably ignoring because everybody ignores failure states until, you know, later on. And so now I've got all this stuff in one big, you know, if then, you know, chunk of my render component. And then then it's like, where do you put the query, right? Like, who owns the query? Does the query live in some other file of like GraphQL queries and it's just exporting a bunch of constants and I import that? And that's useful in some ways because then if I'm doing optimistic caching or using some of Apollo's caching stuff, I need to get that query anyway. So like, do I name it and put it in an external library and then pull it in from my component that's going to do the query, but also a component that might be updating the cache based on that query, right? If you use optimistic caching, you have to have the query that was originally run to, you know, fill the cache to use as the key to then change that cache.
Right.
So, but then we were thinking, well, you really want to co-locate your query with your result. Like, that is the best user experience. The best user experience is, hey, run this query, and with the result of it, put it on the screen. Everything's together, right? Like, you're not having to bounce between files or reference some GraphQL query in God knows where, some other file. You have to dig it up by name and track it down. That's super annoying. So it's like the component that does the fetching should own the query and it should own the result. Okay, so then we're like, okay, so we can do that, but like use query is still not super elegant. And it's like all of these components that are doing this data fetching look the same.
Yeah,
it's just we're defining a query
true.
and then using use query and then running a bunch of if-thens to get to our final or, success and whatever, right? Like you're just, loading in you go down the chain. And it just ends up being boilerplate. So we're like, why are we writing all these bits every time? It's just, it's something that the framework could take up. So then we're like, okay, what if we extracted them out and then just made them available as functions? Because they're all either, a GraphQL query or a set of components. But I don't want to, it would be nice to have them all in the same file, but you could easily create your success state in a separate file and then import it into the cell if you wanted to have, like if you had something that was like, it had a really big success component and a big failure component, a big loading component, you can easily extract them out still. But being able to just think about and look at a cell and just be like, what is my query? What happens when I fail? What happens when I'm loading? And what happens when I'm successful? And if you want, what happens when I'm empty, if it's a potential array return? And then we tried that out and we were like, this is nice. Like it's the bare minimum of everything that you need in order to do data fetching. Right. And you look at it as a user and you're like, I know exactly what this is doing. Yeah. There's no question. There's nothing hidden. There's nothing cluttered about it. And there's also some additional functions that you can use in those that we don't really go to in the tutorials in order to modify the data as it comes in and to modify the data that comes out of the GraphQL query before it goes to the success component. But right, it's like when you're writing your success
do we run into that with the stale while revalidate thing, Ryan?
There's something at the before, I forget the name of it, before something. It let us modify the GraphQL query going out to the server.
Yeah. I think I opened up a second tab, created a post back in the original tab, clicked about, and then went back home and didn't see the data. And then we found this thing where you say network and cache. It's very declarative. And then you do the same thing, and it acts more like the SWR library from Zeit, where you fetch the post, you go to about. As you hit back button, you're going to get an instant render from cache. But if the data happened to have changed, you'll now see the new data there.
Yeah, right.
One really nice thing is you're telling that story about the components being exported and the loading and all those states. It ties back nicely to what you were saying about Storybook, where I can just get a component and see it in the loading state. And I don't have to think about the waterfall of if statements that I have to go through when each of those things are rendered. So that's pretty cool.
Yeah, and we'll build some tooling around Storybook because the cells aren't actually components, right? Like it's a couple of exported functions. Like that's obviously not a component, but the way that you use it from other components is you just call. I mean, it looks like a component. It feels
just like a component, yeah.
Right, and you're like, eventually you forget about it, and you're like, oh yeah, I guess it's not actually like what black magic is that?
I think we realized that like halfway through. You're like, wait, I'm importing the default import, and there's nothing default exported from this file.
Yeah, right. It's a higher order component, and we hook it up for you behind the scenes. But in order to make that work properly in Storybook, we have some work to do because A, it's not a component, right, as is. So we need to get you the higher component applied to it. And B, you're running a GraphQL query in there. Because it's a bunch of exported functions, like we can tell it to not export that query. But now you need to mock out the data that you would be getting from your real database. And maybe you want the option of actually, I don't know, we haven't figured that out yet. Like what is the experience of storybooking a cell? Because it's obviously something that you'll want to do. Like these are the fundamental building blocks of your app. Although a common pattern will also be my success component really is just rendering another pure render component.
Right.
In which case you're not worried about it. But what if that, if that component somewhere in its chain is doing some data fetching, like you want to be able to render the whole thing kind of all the way from the page level.
Right.
Like, wouldn't it be cool if in Storybook it was like, basically here's all the pages in your website and you can see them as a page, as like a full page, or you can look at any component on its own. And you can put
any component in any of those states too. without
Right, and
having
then for
to
every-
like mock data, you know?
Right. And for every component, you could say, here's the data that's coming in that I sort of hard coded in there or whatever. And also I can go in and I can change anything that I want about that return from a data fetch in order to put it into a different state. If I'm really
Right.
interested in the page, sort of like the page level functionality.
Right.
But if I'm only interested in a render component that's down on a leaf of sort of the React chain, then I can go in there and I just pass it some props and I'm good to go, right? But we did struggle with this for a while. At one point, we were thinking about cells being purely data fetching or having a data fetching thing, and that you would never render in the data fetching component, so that you would always be able to storybook it more easily, where it's like, this is a pure function, it takes in props and it renders something. But as soon as you have subcomponents that do their own data fetching, then it's like, well, what does that even mean? So then it's like, well, then we may as well focus on the maximum.
You lose some of the
developer experience.
benefit of being able to couple rendering and data fetching inside of a single component. So it's worth investing in figuring out how to mock that stuff out, so you don't lose that benefit of React, because that's a huge benefit.
Yeah. So that's where we came down. We came down that like the major benefit, the most beneficial thing for the user in authoring this is that you want your query and you want your rendering co-located. That's what's a cell.
Yeah.
And we'll solve this by making it really easy to figure out how to mock the returns from these data fetches.
Interesting. Cool. We work on the data fetching mocking library, actually. It came out of that. Yeah, it's called Mirage, actually. It came out from our Ember work and basically wanting to easily mock out APIs, because this is the kind of thing you run into all the time. So you want to be able to, especially when you don't own the API, and this was for testing too, but yeah, if we're talking to a central API from our company that's owned by another team, well, we want to be able to write our front end and put that thing in any state without even worrying about what the actual database or service is doing. So we could definitely talk about that at some point in the future.
Yeah, that's awesome. Oh, and also it made me think that another benefit of using GraphQL as the transport here and having your data fetching use GraphQL is that if you were to change your GraphQL schema at any point, the framework could be like, remember to update your mock, because like, it no longer matches the shape of the GraphQL,
Definitely.
the actual GraphQL function.
Yeah, having that stuff integrated is really powerful. Maybe before we start wrapping up, Ryan, I know you had some thoughts when we were going through the tutorial about the database. Did you have some questions for Tom about that?
But I don't remember what.
Well, I just figure you'd
I feel
be
like
the
you're
better.
trying to lead me into something
I was.
here.
Well, I was just, we have to try to get him before he goes. Right? No, it was more like I figured you'd be the better person to talk to about, well, we hit the database thing. We had to deploy it to Heroku, and the rest was on Netlify. And then also the Postgres relational NoSQL kind of stuff.
Yeah, definitely. So, as we're going through it, we're imagining, I think there's multiple times you mentioned like Lambda functions and how this just gets deployed. And it's such a cool feeling when you just like push your app and it's the back end is all pushed and everything when, you're not pushing two separate apps. But then, we hit the point where we had to go manually set up a Postgres database and manage that. I just wanted to get like, what are your thoughts of like, what is that going to look like in the future of managing databases alongside these web apps?
Yeah, I would love for it to be easier. And I've definitely talked with Netlify about making it easier to provision databases. It's a bit outside what people currently think about from a JAMStack perspective, which is what, our tagline for Redwood is bringing full stack to the JAMStack. And so the database is obviously a part of this equation and pushes the boundaries of what people think of currently as what is JAMStack. Usually you're not thinking like, oh yeah, I'm going to have a database and I'm going to have business logic. That's not usually how people think about it. But when Netlify came out with functions and had the demo where it was like, yeah, you just write your AWS Lambda function in this file and put it in this location in your repository and push it to GitHub, and then we will deploy that for you. Like that blew my mind. And I was like,
it's incredible.
This is now could be the fundamental framework for something that I've been searching for a very long time, which is, I call it a universal deployment machine, which is essentially you write code, you press a button and it's running and you don't care how or why or where. And I think we're still a ways from that, but I think we're getting a lot closer. And right now, with thinking about delivering your single page app on CDN, where it's like you write a fully fledged React-based SPA and you put it on a CDN and you can deliver that instantly, no matter where someone is. And then you couple that with the ability to deploy your business logic as a GraphQL API to AWS Lambda, which you could also put near the edges or where your users are. Then the last piece is you need your database to also be where your users are. And you can do that currently with read replicas. And databases are becoming more and more sophisticated, even around distributed writes. And so I envision a future. It'll take a little while to get there, but Redwood is really trying to build and conceive of this architecture that is tomorrow's architecture. Like, it's still a little clumsy today, right? Which you see where it's like, oh, go, this is going to be amazing. You're just going to push to Netlify, push to GitHub. Netlify is going to pick it up and like you're done. And you're like, oh, one caveat, go set up a database on Heroku. And you're like, oh, you were so close. Like, you had me until I had to go set up my database, right?
It's so frustrating too, because every one of those steps adds like 3 steps of the integration complexity. So just like y'all getting Prisma to talk to Apollo is like not just right. Prisma and Apollo, it's like n times n times n. So it's the same thing here.
Yep. Yeah. So now you got to go set that up. And if you really want to do it right, you're going to use a globally distributable database in AWS, but now you're managing your own AWS Aurora database or whatever, and you got to figure out how to get that into the same VPS as like your stuff in your Lambdas in Netlify. So there's still that level of complexity, but I think it's all manageable. I think that we'll get there. And even beyond that, Redwood really wants to have a first-class experience with multiple databases. So it's like you use a Postgres maybe, and you use FaunaDB. Or maybe you're using Mongo or something, but maybe you're using a relational and a non-relational database for different parts of your application because they match better, right? Like if you have some unstructured document that's associated with a user and you don't need to do joins across it, then it's like a document database could be much better suited for that. And so maybe do that, right? And eventually Prisma will have integrations with all of the databases. And you'd be able to very easily just say, oh yeah, grab this data from this database and this data from this other database. And all that's really easy. But that's still too much management for me. What I would prefer is a future where you have the database that is distributed and over time understands what queries are being run by your application and can optimize that automatically on your behalf.
Sounds like a good future. I mean, that's like, basically it's like, every app we've worked on has used MySQL, Redis, and Elasticsearch, right? So like the idea of you either want, it's the worst of all worlds today, right? On the one hand, you need 3 databases. And so now you are responsible for the infrastructure for all 3 of them, making sure every environment is running all of the services and that they can all talk to each other and your application code can talk to them. On the other, if they were all basically conceptually part of the app, the way the functions are, the Lambda functions are in Redwood, then you don't care as much about it. So if you had that world, you wouldn't care as much because even though in a Redwood app, there are 2 applications being deployed. We never felt like that while we were building it or deploying it, right? Which is such an important part. Or as an alternative, if of course you had one silver database that could do everything, that would be wonderful as well.
Yeah. And I mean, I don't think it's impossible that we get there. I think it's going to take some time, right? But like machines are good at this stuff. Yeah. Machines are really good at this stuff. It just takes the code to get them there. But imagine that world where it's like, here's a database. It's relational and non-relational, depending on what your needs are. And it's easy to create read replicas around the world. And we'll figure out what the right amount of replication that is for your specific needs. And we'll optimize your queries in such a way that, why are we adding indexes? It's like, what?
Yeah.
Like, this is work that machines
you're preaching to the choir
and
right
should
now,
be
brother.
Doing. It's just code, right? It's just code that gets us there. It's just,
Yeah.
it's hard. I mean, I'm not trivializing how hard this is.
Sure,
This is super,
sure,
super
sure.
duper hard. But I think
Yeah.
we can get there.
Yeah. And maybe we can get there for a threshold of application that a lot of us operate at, right? I mean, if columnar storage is always going to be better at the kinds of queries that you do against those kinds of databases, maybe than row-based storage databases, but maybe the how fast a row-based database can get at those kinds of queries can just move far enough that 90% of startups, 90% of back office apps are going to be just fine with it. So that would be fine with me. But I think it's also cool that it would be fine with me if I do have 3 services that I need, but they're just 3 different folders in the root of my app, and something like Redwood just deploys them. I mean, that really changes the game from my perspective as someone who has spent hours trying to get, whatever, Postgres running on my shell, whatever it is. I don't want to deal with that stuff anymore. I mean, these services have gotten so good these days that my threshold for this is so low. And so even if you give me a pure crystal backend environment and a front end environment, but now I have to set an environment key variable in my 2 environments and deploy them independently to talk to each other, you've just almost basically lost me, right? So that's just part of the story. And so the integration story that y'all are focusing on, I think, is really crucial.
Yeah, absolutely. Managing secrets, like all this stuff is annoying. It's just like, can I please have a database and a Redis and an Elasticsearch? And like, why am I configuring this stuff? Like, just give them to me and hook them up for me. Yeah. And I actually talked with a startup yesterday that is doing something that's kind of like that. And it's super interesting to me. Like, just the idea, like, how easy can we make it to provision and use and hook up and integrate these infrastructure items? Because we need these things.
Yeah.
And we're not getting them. We don't get them from the JAMStack right now.
I mean, it goes back to what you said, which is like, I love Rails, but I don't want to write Rails anymore. Like, when you said that, I was like, that's so true. Like, I love Rails. It does this integration for you, but I just don't want to write Rails anymore. So can we get this in with a React app on the front end or whatever? There's modern tools on the front end,
Yeah, that's what we're after.
Cool. Well, I think that is a great place to wrap it up. Tom, thank you so much for joining. I know our audience is going to love this conversation. I know I did. And I had a lot of fun playing with Redwood today. And learned a ton. So thanks again for Redwood, for all your open source work, for GitHub. I mean, we are huge fans of your work here. So we really appreciate you continuing to push technology forward and investing your resources into projects like this that make all of our lives more pleasant. So thank you so much for your work, and thanks for being on the show.
Appreciate it. This is what I love doing. Thanks for having me. Oh, and I should mention that if you want free Redwood stickers shipped for free anywhere in the world, you can go to redwoodjs.com/stickers and fill out the form, and I will ship 3, maybe 5 stickers to you. We've shipped them to like 60 different countries now. So
that's awesome.
Anywhere in the world. If you can type your address in my address form, and that will actually work to get it to you, then I will send them.
And all the services are running. Well, you can't turn that down, folks. That's an offer too good to turn up. So thanks again, Tom. Thank you, everyone, for listening, and we'll see you next week.
Thanks, Sam. Thanks, Ryan. Bye.